Alright, so 1.4 part 2. Yesterday for part 1 we were solving systems of equations with 2 equations. Today we're going to move on to solving systems of equations with 3 equations. So a linear equation in 3 variables, we have x, y, and z. So yesterday we just had x and y. Today we're throwing in z in there. Is an equation of the form a times x plus b times y plus c times z is equal to d, where a, b, and c are not all 0. So again, we have to have it in this order where we have our x, our y, our z, and then equals to our number. So the following is an example of a system of 3 linear equations in 3 variables. So here we have it in the correct order. We have our x's lined up, our y's lined up, our z's lined up, and then equals to our number. A solution of such a system is an ordered triple. So we would have x, y, and z whose coordinates make an equation true. So let's move on to our first example. So to solve this system of equation, we're doing the same thing that we did yesterday, but here we have 3 equations. We just need to take it 2 equations at a time. So first thing we're going to do is eliminate a variable from 2 of our equations, and then we have to do it from a different, so then we're eliminating the same variable from a different group of 2 equations, and then we take those 2 new equations that we have and do the same thing again. So here we just have to add in a step in the beginning where we take 2 equations at a time and eliminate a variable. So looking at our first 2 equations, we can ignore the last one for now. What variable should we try to eliminate here?
Z.
If we try to eliminate z, we would have to multiply both of our equations by something. So we could multiply the top by 5 and the bottom by 3. That way we could get 15. One of them would have to be negative. So we would have to be doing more work than what's needed. We could eliminate x just by multiplying our second equation by -2. So we could have done z, but we would have had to multiply both of our equations by a number, which would have been more work. So to make it easier for us, let's eliminate x, and all we have to do is multiply our second equation by -2. That way our x's are going to cancel out. So we're multiplying everything in our second equation by -2. So our second equation, I'm going to rewrite it down here. We have -4x plus 6y plus, or this would be minus 10z is equal to +14. So now we're combining equation 1 and our new equation 2. If it helps to see it, rewrite equation 1 down here so we can line it up. So we have 4x plus 2y plus 3z is equal to 12. So all I did was just rewrite equation 1 below it so we can line them all up. Now we combine the 2. So our x's cancel out. 6y plus 2y becomes 8y. -10z plus 3z becomes -7z. And then we have 14 plus 12, which is 26. So now that we have an equation with just 2 variables, we need to do the same thing and get another equation with just 2 variables. So we could either look at the first and the third, or the second and the third. Let's just take these 2.
I have a question.
Yes.
How did you get, how do you know when to multiply to make it, what are you doing there? Because I'm really confused.
Okay, so We need to multiply one of our equations by a number to get one of our variables to cancel out. So we picked, and we can pick which variable we want to cancel out. So we picked x's, and in order to get our x's to cancel out, we need to have opposite x's. So if we have a positive 4, we need a negative 4. That way they're going to cancel out with each other. So we need to get this 2x to look like a negative 4. So that's why, and to get that 2x to be a negative 4, we have to multiply it by negative 2. But if we do that, we have to multiply everything in our equation by negative 2. Okay, so looking at our second two equations here. So we have equation 2 and equation 3. We have to eliminate the same variable that we eliminated the first time. So we have to eliminate our x's here. So we need our 2x to look like a negative 6x to get those to cancel out. So what do we have to multiply by 2x to get it to look like a negative 6?
Negative 3.
Negative 3. So we're going to multiply everything in our equation by negative 3. So I'm going to rewrite equation 2 down here. Negative 3 times 2x is negative 6x. Negative 3 times negative 3y is a positive 9y. Negative 3 times 5z is negative 15z. And then negative 3 times negative 7 is 21. Now I'm just going to rewrite equation 3 down below here so we can line it up. But you don't have to rewrite it if you don't want to, but I like to because it makes it easier to see and there's less room for error. So our x's cancel out. We have 9y minus y, which is just 8y. Negative 15z plus 4z is negative 11z. And then 21 minus 3 is 18. So now that we have our two equations with two variables, we can now take these and do the same exact thing that we did yesterday. We line them up and eliminate a variable and then plug it in. So we have 8y minus 7z is equal to 26, and 8y minus 11z is equal to 18. What variable do you think would be easiest here to cancel out?
The y.
The y. And what do we have to multiply by which equation to get our y's to cancel out?
The top by a negative.
Perfect. We could multiply the top or the bottom by a negative 1, but let's just multiply our top by our negative 1. So we have to multiply everything in our equation by negative 1. So I'm going to rewrite the top down below. So we have negative 8y plus 7z is equal to negative 26. So now I'm adding these two equations together. So our y's cancel out. Negative 11z plus 7z is what?
I have a question. Why didn't we just take out the y? Why do we have to make it a negative?
We have to have opposites so they'll cancel out. So if we have a positive 8y, we need a negative 8y so they'll cancel out. Just being like 8 and 8, if we added those together, we get 16, which our goal is to cancel one of them out. So we need to make one of them negative.
Oh, okay, thank you.
So now that our y's cancel out, we add negative 11z plus 7z, which gives us negative 4z. And then 18 plus a negative 26 would be negative 8. Then we just solve for z by dividing negative 4 on both sides. So we get z is equal to negative 8 divided by negative 4 is positive 2. Now that we found one variable, we can take that and plug it back into our equations. We have to plug it into one of these two equations because we can't go back to equation 1, 2, or 3 because there's still 3 variables there. So then if we plug one of them in, we still have 2 unknowns. So we have to plug it into one of these two. It doesn't matter which one of these two. I'm going to plug it into the first one. So we have 8y minus 7 times 2 is equal to 26. So I'm just taking z is equal to 2 and plugging it into our first equation here. So 8y minus 14 is equal to 26. I'm going to add 14 to both sides. So I get 8y is equal to 40. Divide both sides by 8. What do we get for y? Five. Good job, Brooke. So now that we have 2 variables, we can go back to one of our first 3 equations and plug in our z and plug in our y. So I'm going to plug it into the first one. We have 4x plus 2 times y, which we said our y was 5, plus 3 times z, which we said our z is 2, is equal to 12. So 4x plus 10 plus 6 is equal to 12. 4x plus 16 is equal to 12. Minus 16 on both sides. So 4x is equal to negative 4. What do we get for x?
Negative 1.
Negative 1. So these are 3 answers here. And we could write this as a coordinate point just by putting our x, then y, then z. So this would be negative 1, 5, 2. Okay, example 2. So we just need to take 2 equations at a time and eliminate a variable. We can pick any of the 3 to do, so I just like to pick the top 2. And then we can pick x, y, or z to eliminate. Do you guys have any preferences? Which one do you want to eliminate?
We could do negative 5 and cancel all of them.
Okay, so if we multiply everything by negative 5, so I'm going to rewrite it down here. We have negative 5x plus, or this would be minus, 5y minus 5z is equal to negative 10. I'm going to rewrite our second equation right below it just so I know that these are the 2 that I'm combining. So our x's are going to cancel out. 5y plus 5y cancels out. 5z, negative 5z plus 5z cancels out. So we're just left with 0 on the left side. And then on the right side, we have negative 10 plus 3, which would be negative 7. Does 0 equal negative 7? No. So what do we do here?
put no solution.
No solution. Awesome. So here we have no solution. Any questions on this one? Are you guys ready for the next one? Okay. So example 3. Just looking at the first two here, we already see that we have a positive z and a negative z. So those are going to cancel out. So let's just go ahead and cancel out our z's. So we're going to add our first two equations together. So x plus x is what?
2x.
2x. Negative y minus y is what?
Negative 2y.
Negative 2y. We said our z's cancel out. And then that's equal to negative 3 minus 3, which is negative 6. Now we can pick our second two equations. And again, we have a negative z and a positive z, so those are going to cancel out. So we can just combine them before we even have to multiply anything to them. So x plus 5x is 6x. Negative y minus 5y is negative 6y. Our z's cancel out, and that's equal to negative 3 minus 15, which is negative 18. Now we need to combine our second two equations to get one of our variables here to cancel out. So what do you want to cancel out, our x's or our y's?
Our x's, and we can multiply by negative 3.
Awesome. So we multiply everything in our top equation by negative 3. So the top equation becomes negative 6x. Second one is plus 6y. And then the third thing we have to multiply, negative 6 times negative 3 is positive 18. Now we can combine our two equations here. So 6x minus 6x cancel each other out. What's negative 6y plus 6y?
0.
0.
Which cancels out.
And then negative 18 plus 18?
0.
0. So what do we do here? What do we get?
All solutions.
All solutions. Perfect. Ready for the next example? Okay, example 4. Which two equations do you want to work with to start, and what variable do you want to cancel out?
We could do the first and the last and cancel out the x.
Okay, so let's do the first and the last. I'm just going to rewrite the first down here, just to put them on top of each other. So our x's cancel out. What's 2y minus 2y?
0.
0. So those cancel out. And then we have 4z plus z, which is 5z. And then negative 9 minus 11 is negative 20. What do we do now that we have two variables that cancel out? What do we do?
Divide by 5z, right?
Divide by 5. We can just solve for z. So the 5's cancel out. We have z is equal to negative 20 divided by 5, which is negative 4. Good job, Sandy.
Thank you.
Now that we found an answer for z, we can plug it in, but the only equations that we could plug it into would be one of these three, and we're still missing two variables. So let's just plug it into the first two, and then we'll have to do our elimination again and eliminate a variable. So we have, I'm just rewriting the first two to the right here. Let me change my color. We have x minus 2y plus, this would be minus 4, because z is negative 4. That's equal to negative 11. And then our second equation, so I'm just rewriting this one by plugging in z. We have 3x plus 2y minus z, so this would be plus 4, is equal to 7. Now we can add the 4 to both sides of our first equation. So our first equation now becomes x minus 2y is equal to negative 11 plus 4 is negative 7. And then our second equation, when I subtract 4 on both sides, is 3x plus 2y is equal to 7 minus 4 is 3. Now we can take these two equations and add them together. So 3x plus x is 4x. What happens to our y's?
They cancel.
They cancel. And then 3 minus 7 is negative 4. So what do we get for x? What do we get for x?
Negative 1.
Negative 1. Okay, now that we found our x and our z, we can take both of these and plug it back in into our original, one of our original equations. It doesn't matter. So I'm just going to plug it into the first one. So we have our x and our z that I'm plugging into the first one. So when we plug it in, x we said is negative 1. So we have negative 1 minus 2y plus z, which is minus 4. And that's equal to negative 11. So negative 1 minus 4 is negative 5. So 2y minus 5 is equal to negative 11. Add 5 to both sides. So negative 2y is equal to negative 6. Divide both sides by negative 2. And any questions from this one? All right, let's look at one more. So example 5. Which two equations do you want to pick and what variable do you want to cancel out?
first two, multiply the first one by -4.
Okay, we can do that. So let's pick the first two. And we multiply the first one by -4. So our first equation becomes -4x minus 4y plus 4z is equal to 4. And then I'm going to rewrite our second equation right below it. 4x plus 4y minus 4z is equal to -2. So I'm just rewriting this one down here. So our x's cancel out, -4x cancels out with +4x, -4y cancels out with +4y, +4z cancels out with -4z, so what are we left with on the left side?
0 equals 2.
0 equals 2, so what's our answer here?
No solution.
No solution. Any questions on this one? Alright, this one is pretty easy. Let's look at our last one here. Which two equations do you want to pick and what variable do you want to cancel out?
The first two and cancel out the y.
Alright, perfect. Let's look at our first two and cancel out the y. So our y's are already opposites of each other. We have a positive y and a negative y. We don't have to multiply anything to get these to cancel out. So we're just going to add our two equations together. I'm going to write it on the side over here. So x plus x is 2x. Our y's cancel out. Z plus z is 2z. And that's equal to 8 plus 8, which is 16. Okay, now we have to pick a different pair, but we still have to cancel out our y's. So which two equations do you want to pick now?
Could it be either one? Could it be like anything?
It could be anything. We just have to pick two, and we can't pick the same first two that we picked last time. So we have to include the third one, and do you want to use the first or the second? But remember, we're canceling out y's. So which one do you think would be best? The second. Our y is already negative, so it'll already cancel out. So the second would just be an easier choice. Which we would get the same thing if we picked the first. We would just have to multiply the first one by -1, or the third equation by -1. So it would just be more work. But we can just pick the second too. So x plus 2x is 3x. Our y's cancel out. Z plus 2z is 3z. And then that's equal to 24. All right, now that we have two equations with two variables, again, we need to add them together, so we need to get one of our variables to cancel out. So what do we need to multiply to which equation to get something to cancel out?
$16 times 2 to get, no, never mind.
So what's our least common multiple of these two?
6.
6. So we would have to multiply the top by 3 to get 6. And then we want our bottom to be -6, so we would need to multiply everything in the bottom by -2. So our top equation becomes 6x plus 6z is equal to 16 times 3. 48. And then our bottom equation, we need to multiply everything by -2, so we have -6x minus 6z is equal to -48. Now that we can combine these two equations and cancel out one of our variables, we see the x's cancel out. What happens to our z's?
Cancel.
They cancel. So what are we left with on the left side of our equation?
0. Because
0.
they cancel out too.
And then what about 48 minus 48? What does that give us?
0.
0. So what happens when we get 0 is equal to 0?
All solutions.
All solutions.